Hello, everyone. My name is Queenie Lopez, and I'm going to present the plant fibers as reinforcement, their characteristics, properties, and applications. So, as you know, many of the materials used worldwide come from petroleum. Petroleum is a known renewable natural resource, and that has a lifespan of approximately 50 to 60 more years. So that's not the only problem. Pollution produced by the industry and not degradable solid waste are part of the main problems and causes of the climate change, the most important environmental problem in the human history. So it is necessary to rethink a strategy for manufacturing materials that are functional and at the same time sustainable. In this sense, the use of the plant fibers as a raw material to develop different types of the materials represent an opportunity for a more sustainable industry. With a growing market, and in fact, in 2020, last year, composite materials with plant fiber reinforcement accounted for the 28% of the total market of the materials. So this is a good opportunity. And also with adequate processing, they could have very highly acceptable and competitive properties with respect to the traditional fibers, such as the glass fibers. Plant fibers have always been used around the world and have multiple applications, from textiles to structural materials. Furthermore, their production, processing, and marketing has never stopped. We continue to use plant fibers as the raw material for many products. In fact, Ecuador is one of the main producers of one of the most widely used fibers in the world. And this fiber is the abaca. The plant fibers can come from very multiple sources, including stems like the bamboo, fruits like coconut and pineapple, leaves like the sisal, and even we can use wood such as soft and hard wood. But at the industrial level, plant fibers have a greater application in the production of the composite materials. So we can call these materials like biocomposites. And the factors that influence the performance of this type of materials are the interfacial adhesion, the effect of the fiber orientation, the effect of the volume fraction, the composition of the fiber, both chemical and microstructure, architectural microstructure, and the type of the matrix. And there are also several biological and environmental factors that we can consider to influence the plant fibers, such as the humidity, genetic variability, and the state of the maturity of the plant. And the process of the biocomposites begins with the selection of the plant fibers and the matrix. The matrix is generally a polymer, which can be thermoplastic or thermoset, and with a specific manufacturing process such as injection or thermoforming, we can obtain very different products. And even we can try to obtain nanocomposites, and we can apply some processes such as electrospray or sintering. So we can see here the types of polymer matrix that we can use. We can use petro-based matrix and bio-based. And we can choose a not biodegradable and biodegradable matrix. So we have a lot of options to mix the plant fibers with the matrix. And another important thing to mention is that we need to include a pre-treatment for the plant fibers. So this pre-treatment could be chemical, physical, mechanical, biological, or a combination of this. And that is due to the high heterogeneity of of the fibers. So regarding of the properties of the biocomposites, there are two important types of the properties that we need to evaluate or measure to imagine their performance. So the first ones are the physical properties, and we have two important concepts here. One is the unit weight and the density, and this is an advantage for plant fibers since they have less density than those of other types of the fibers. And the second is the air content, which must be less than 2% to avoid the transversal faults. And the second important properties that we need to evaluate is the mechanical properties. And we can include the dispersion homogeneity of the fiber reinforcement in the matrix, the good interaction between the reinforcement and the matrix, the low porosity of the matrix, and the adequate amount of the reinforcement in order to allow the continuity of the matrix. So more specifically, mechanical properties, we have the tensile properties, which depends mainly on the nature of the reinforcement and their orientation, as we saw in the past slide. The flexural properties, which depend on the two main factors, which are the modulus of the composite materials and the moment of inertia. The compression, which depends on the architecture. This architecture could be natural or tight, and the volume of the fibers in the matrix. The fatigue properties, it has been proved that the mechanical resistance decrease with each cyclical load, and the viscoelastic properties. It has been proved also that the addition of the plant fibers shown an improvement of the dynamic behavior of all materials. So the application are very diverse with this type of biocomposites and include textiles, furniture, thermoformed panels, parts of the cars and bicycles, prosthetics, even prosthetics, construction material, and decomposable products, and many others that we can use every day of our life. So as conclusion, we can say that the advantage of this type of materials are the low cost compared to the manufactured fibers, lower density and unit weight, a greater flexibility, good resistance to traction and thermal and sound insulation, low energy consumption. They can be totally eco-friendly and more sustainable if we include some concepts or circular economy and social responsibility. And among the disadvantages are that the mechanical properties don't exceed the conventional fibers, such as the glass fiber or carbon fibers and others. And especially to face the forces of impact, and they have a lower durability. That's a important problem, and high heterogeneity, and therefore it is difficult to model their behavior. And despite all of this disadvantage, we have a really big opportunity as a country to produce and develop some products made by a more sustainable raw material. Thank you very much.